Hey everyone, welcome to the Tom's Hardware Podcast for today, October 24th, 2023, or otherwise known as day 2 of the Raspberry Pi 5 era, if you count it from the day that people could actually buy it in the store or have their pre-orders delivered. So that's super exciting. And as always, I'm Tom's Hardware Editor-in-Chief, Abram Pilch, joined by Associate Editor Les Pounder, Raspberry Pi expert Ash Hill, and our very special guest, James Adams from Raspberry Pi, here to talk to us about the Pi 5 and all the great things that are going on with it. And so, what a perfect time to have James on, talking to us and taking your questions about with Raspberry Pi 5's Raspberry Pi's chief operating officer. How are you doing, James?
Yeah, I'm good. Thanks for having me on, Abram. It's nice to see you guys. It's exciting to come and talk about this stuff, given how long it's been in development, depending on how you count it. I still count it as 8 years because the end of 2015 was when we started the chip program to do the RP1 chip. So I think Pi 5 has been in development for 8 years. Of course, other things are slightly less long, but it does take a long time. Or this one certainly has taken the most time.
So 2015 was Raspberry Pi 2, if I remember right?
Oh gosh, yeah. My memory's bad for this, but yes, I think so. Yeah, I think we were not far off launching 3, were we? So 14 was the compute module, and B+, yeah, and then 15 was 2. And fairly quickly after that, we had 3.
Yeah,
but we had the idea for this kind of companion chip quite a long time ago, and the way it really got started was we had some. So we're all chip designers, or a lot of us at Raspberry Pi chip designers by background, and we had some friends who'd gone to a startup that was winding up because they couldn't get funding. We'd had this idea to do a chip, so they came on as contractors, 3 of our friends, and kind of started contracting just to see if this thing was feasible. And that's how it started to sort of wind up, and eventually we got to a state where we knew it was feasible, we could afford it, we knew what we wanted to do, and we sort of brought them on full time, and that's how the team got started.
That's interesting because you've got in Raspberry Pi 5, it's got a quad-core CPU, it's got multitudes of RAM, 1, 2, 4, 8 gig. But for me, the exciting part is the RP1 chip, the South Bridge, everyone's calling it. So what does that chip actually, what's it connected to on the board?
So the main processor is the Broadcom 2712, and obviously that was designed by Broadcom with input from us. If you look at the Pi board sort of front on, and when I say front on, with the micro HDMI ports pointing downwards, because people often tell us the silk screen's upside down, but with the silk screen the correct way up, if you look to the right hand side where the RP1 is, between those 2 chips there's a big pile of wires and a little rectangular components which are capacitors, and that is a 4-lane PCI Express Gen 2 interface, and that's what connects the 2712 chip to RP1. So that's the pipe between the 2. Yeah. I guess what does RP1 do for us? Well, it's the GPIO, the USB, the MIPI, the camera display, and we've got a TV out on there as well. And really what the idea for the chip was to take the Raspberry Pi stuff and put it onto this separate device. And what that does is because this stuff is quite fixed, because it's been pretty similar over all the generations. Also, as you make the main SoC go down the nodes, so we had 40 nanometers was the Pi 3 generation stuff, 28 nanometers Pi 4 2711, and we're now on 16 nanometers for 2712. The analog, the sort of the USB PHYs, the PCI, you still need that on the Broadcom chip, but the sort of the other things like the MIPI PHYs and all this kind of stuff, it doesn't scale very well as you go down to the smaller nodes, so you end up paying more and more for these sort of functions. But also, it sort of allows the main chip not to need all of that extra stuff every time you do a design cycle. So it makes the main chip simpler and takes away all this stuff that doesn't scale very well. So that's the main idea behind it. And actually, it's worked very well on Pi 5.
Yeah, That's great. So what would you say are some of the functions that you're most excited about on Pi 5 that folks couldn't do as well or couldn't do at all on Pi 4?
Well, my most exciting feature is the power button. That's nothing to do with RP1, but like I'm a simple man. I like holes in the right place and power buttons. So people have wanted a power button for a long time, including me, and we finally managed to squeeze that on, which has been, funnily enough, quite an effort, because you need to find the right kind of button. So I went through a few options, and it moved around a lot across the prototypes, so we could get it all right with the case and the LED. So, funnily enough, that was actually quite a lot of work, and we had to integrate the power button functionality into the power management chip, which is also new for Pi 5, and you'll see it just above the USB-C connector. There's quite a lot of pieces that have to work nicely together to make that functionality work nicely. Now, of course, you could have done it on older Pis with lots more external circuitry and stuff, but that costs money. So it's not then just the few cents of a switch; it's also the extra stuff that you need to make it work. So, kind of had to come together with the power management chip really to make it happen.
Regarding the RP1, can you talk a little bit about what its original purpose was and how that changed throughout its development? Because you said it took about 8 years.
Yeah. So I mean, Raspberry Pis have always been kind of a two-chip architecture right from the very beginning. So the original Pi generations used this USB hub and Ethernet chip. So you had a USB 2 to an external chip, which did the 4 USB 2s and the Ethernet. On Pi 4, that changed a bit. So we use the VLI PCI Express to USB bridge, does the USB. The Ethernet moved back onto the 2712, which is why we had to move the Ethernet connector, unfortunately, from the bottom to the top. And now on Pi 5, we've moved it back to its rightful position. because we planned the RP1 chip before Pi 4. And so we kind of, we had this flip-flop. And so the RP1 is designed to have the Ethernet down the bottom. But yeah, so there's always been this two-chip design. So for a long time, we've known this. And for RP1, it's designed to fit that socket, but also, as we've sort of talked about before, to make designing the platform easier. You put all this slightly difficult and not very well scaling stuff onto one chip, and it doesn't really change very much. And also things like USB. So RP1 has 2 USB controllers in it, so it's got a lot more bandwidth than any other IO processor or Southbridge, because it's got 4 lanes PCI Express, which is 20 gigabits raw, sort of 2 gigabytes a second bidirectional. So there's a lot of bandwidth. So we've got 2 USB 3 controllers in there. So each of those USB 3 connectors you can get basically full USB 3.1 bandwidth, so 5 gigabits. So if you take 2 SSDs and you're copying from one to the other, you get pretty much full transfer rate. Whereas on the previous generation of Pi 4, the VLI chip has a 1-lane Gen 2 PCI Express, which is kind of 4 gigabits. So you can't even get full USB 3 bandwidth out of that. And it's sharing it across all 4 ports. So, things like that, where we're able to make a meaningful difference to some of this stuff. We don't have to take off the shelf silicon. We can really engineer it the way that we'd like to engineer it. Plus, we've also, because it's been it's in development for a long time, we've managed to roll a lot of bugs out of the USB controller, for example. We had a couple of bugs that we found in there over extensive testing, and we managed to fix them before the chip became production. So I think it's, there's the value in doing this, right?
Yeah.
And also, why did it take 8 years? Well, it took a long time to spin the team up. If you're going to spin up a chip team, even if you hire people have done it before and you've done it before yourself, it's a big effort, right? It's really non-trivial. And actually, the first generation of the chip was supposed to be on 3B Plus a long time ago. And we designed some wacky way of trying to use the 2837, the Pi 3 generation chips had a spare camera and display interface, MIPI. These are serial camera display interfaces. We had a wacky way of trying to reuse them to talk to the Southbridge. And we kind of prototyped it. We got it to work. We even taped out a test chip. So there's a test chip that exists that uses these as data transfer instead of PCI Express. But once once we taped that out, I mean, even before that, we kind of knew that we needed to use something better, and PCI Express was a pretty obvious standard to use. We also knew that 2711, and we knew that we wanted that to also exist on 2712 in the future. So we kind of had this PCI Express link coming. So we swapped to that and we re-engineered the chip. And over time, you do the first one and it's a bit simpler. And we kind of we didn't start again, but we added a lot of cool extra stuff like the dual USB 3 controllers. And because you got a link with much more bandwidth, it kind of allowed us to do a lot more stuff. So that's why it took a long time. And also in between doing this kind of thing, the team also did RP2040. So they've been a busy lot.
Yeah.
They have been busy, yeah.
So Tough Manjel, I hope I'm pronouncing your name correctly, says Pi 5 good update, but I can't understand M2 NVMe. Why not add? Well, we sort of have M2 NVMe. You have a PCI slot which will connect to it.
Sure. I mean, did you want to talk about that? I mean, the design decision. Well, why not? People say, well, why didn't you put M.2 on there, for example? Mm-hmm. And the answer to that really is that, well, there's several answers or several combinations of things that makes it difficult. One is that we don't really have the board space. Second is that M.2 requires quite a lot more juice. I think it says kind of a 9-watt spec, so you have to be able to provide 9 watts to these things, which would make the power requirements. You need extra circuitry to make that happen, and also, the Pi isn't long enough for a big standard size drive, so it didn't fit, and it would cost money. Basically, is the answer. So we decided to put the smallest possible thing we could put on there, this little FFC connector. So you've got PCI Express Gen 2, although it does tend to work at Gen 3. It's not really specified for that. Your mileage may vary. Just the one lane and a couple of control signals, and that and some power, and that that's kind of, we've gone the Pi minimalist approach. Really, it's kind of one connector and minimal cost, but that also allows you the flexibility to do different things, right? So we are going to release this M.2 hat, so that you'll be able to plug in your disk drives. In fact, first demo thing. So this is probably a picture that you've seen floating around the web of a demo one, and this does work. It's not what the final one is going to look like, because it's got an RP1 on. It's got all prototyping stuff on. So this isn't right. It'll probably look fairly similar, but it's really not going to have all these connectors and whatnot. But there's things you can see it. You can fit the blower in the middle. So one of the things you do need, come on finger, I can't do this while looking at the camera, but you can see the FFC. Nope, there we are. FFC. That does need a controlled impedance FFC, so we'll supply a flex with it as well, to make sure that the signals have a nice channel to travel up. If you just use a standard one, it's kind of a bit iffy. But it does work. It is coming. We're going to release the spec as well for the connector. The only reason we haven't done that yet is the control signals. We've been debating how they're going to work and how the firmware is going to work with that. And so, pretty soon, as soon as we get our next prototypes of that product and it works, which it should do, because it's simpler than the one you've just seen, then we can kind of say, yeah, we're done and we'll release the spec. But it is coming, and it really does make a difference to boot speed. And of course, then people can worry less about SD cards having issues. I mean, that still seems to be a Pi myth. We do know that occasionally there are some SD cards that have controller issues and do re-energize the myth that SD cards are not as good as corruptibility, etc. But in general, and we have a big test rig at Pi HQ, which literally we put loads of SD cards in and it runs them and yanks the power and does that 1,000 times a day. And we can, generally they survive pretty well. It's just occasionally you get a kind of a card where there's some bug in the controller. So I guess, two good things. You get more speed, you get NVMe. That this is what people do want, and they will get it soon.
Why not PCIe 3? Why 2?
I guess there's a couple of reasons. One is that PCIe 3 has, this can get a bit technical, it has quite stringent jitter requirements. What this means is the clocks and the data have to be extremely accurate. And what that means is the physical hardware, you need the clocking system needs to be very capable, and that tends to mean it's going to be quite big in terms of silicon area, and so it's quite a heavy cost. Now, I imagine that, in future generations we'll move to 3. So what we've got in this chip is sort of an approximation of 3. So the controller can do 3. The clocking system can't really, but actually it does seem to work. So we're not going to promise Gen 3, but if you turn it on in Gen 3 mode, it kind of works. I think the bit error rate's higher than it should be, and we can't certify it at Gen 3, but it kind of works, right? So it's sort of a compromise for cost. And yeah, that's it really.
So what kind of transfer rates can folks expect if they use this as advertised? Is it going to be faster than connecting an external SSD through the USB port?
Oh, definitely. Certainly at Gen 3. I think when we're running that little tester, test hardware I've got at Gen 3 is about 980 megabytes a second, I think, transfer speed. And, Gen 2 is half that. So, and I think over the USB 3, you'll get about 320, 350. So it is faster. Yeah, for sure.
That's impressive.
But that's only if you run it at the Gen 3 mode that it's not officially supported, right?
Well, you're sort of 480 with Gen 2, I think. So it's still faster than the sort of 320 of USB. And of course, it's NVMe, so it's just a nice... actually, USB 3 is fine as well, but there's just less... There's less translation. So if you've got a USB 3 thing, usually what happens is it's got a USB 3 to PCI Express converter or something in there. So it's just like a nicer way to do this, isn't it? And a smaller thing. You're not hanging stuff out of USB 3. So
definitely so. Everyone's going to be very excited about being able to boot off of an M2 drive for sure.
I have a question about that actually, and it stems from an article that I read. It was put together by Jeff Deerling. Jeff got a hold of a Raspberry Pi 5 early, and he's had his hands all over it. And he recently posted just a few days ago about booting from an NVMe SSD and how he is able to boot from it as long as it's connected directly to that externally exposed PCIe lane. However, if it's connected to a switch, he can still access it, but there seems to be some kind of restriction in place as far as booting goes.
It's not really so when you boot, the boot code has to enable the PCI Express link, and it has to then talk to the drive and get, be able to access it. So if you put a switch in the way, that's another level to configure, right? So the boot code has to do more stuff. It has to configure the switch and then understand that, there's the thing that's behind the switch that I can boot. So it's just we haven't done that work. I think it's not something that's a priority for us at the moment, just because there's a whole ton of other stuff, and it's a new platform. So we release all this stuff, and there'll be a ton of things to change and fix and feedback, and how it goes. So the team's going to be pretty busy for the next few months, but we're aware that it doesn't work, and it may get some more priority. We might find people with particular use cases where it's like, we need to make that work. But probably not anytime soon.
Yeah, that makes sense. So Avinash asked, do Pi 5's thermal throttle without the fan but with this heatsink? I think we've tested that.
Is that with or without the fan, I guess?
I guess with a heatsink, but no. I guess if you put a heatsink on it but no fan. Les, you tried that, didn't you?
I tried it with some very basic Amazon heatsinks, and it would run, but it would thermal throttle. But it would take just a little bit longer to get there.
So I think the answer is it depends. What you've got two FX. I recommend using the fan, which is why we built the blower fan heatsink thing, or you can use the case with the fan in. Even with quite big heat sinks, if you're running the thing quite hard, it takes longer to throttle for sure. And part of that is just the thermal mass, right? It takes a longer time to heat up all that metal. if you orient the Pi so that the heatsink's big enough that there's enough airflow by it, then it's fine. But if you've got even a reasonably sized heatsink, but there's not much air movement, it is going to eventually throttle. But it might take 5 minutes, for example. So this kind of stuff is an interesting thing. We have done quite a lot of experimentation with this, and again, this is why we've released a thing with a fan, because actually you don't need very much air movement to have quite a lot of cooling effect, even with a smallish heatsink. But if you want a passive heatsink, you need quite a big one to stop the thing throttling. And it will depend like what orientation it's in, and is there any airflow, or if you put it in a box, of course, it isn't going to work. But you've got a nice lot of thermal mass you've got to heat up before it throttles. So it's so it really depends.
Yeah, I have to give a shout out to the dedicated fan header on the Raspberry Pi 5, because if you wanted to put a fan on a prior Pi, you would have to use up GPIO pins for that, and now it's built in. So I think that's a great move. You can use the stock this fan, but I'm sure there will probably be third-party fans coming out as well at some point. So I think it's great that you don't have to use up any of the GPIO pins for that. Are there any plans to give users more control over the fan? I haven't seen a way for you to kind of control when the temperature that it goes on, or the amount, or how high it goes, or anything like that.
Yeah, that's a good question. And I watched your previous PiCast with and I saw the question asked there. So I actually asked the software guys this evening, and I thought we had a way to change it, but it seems like perhaps we don't at the moment. But it's in active discussion. So
okay, cool.
Yes, there was a way in Raspberry config, wasn't there, where you could change the PWM pin for the fan for the old GPIO connection for Pi 4.
Yeah. So I'm not going to speak for the software team as to whether we'll do this or not, but I'll just say it's in discussion. But yes, sort of used to be able to do that. So
cool.
Yeah.
That
again, this is one of these feedback things, right? We do stuff. People say, "Hey, I want to use it for this use case," and then often we say, "Oh yeah, well that's quite reasonable. Why don't we fix the software?"
I think it's in great shape considering considering the launch. I mean, everything, especially with the latest version of Bookworm, things seem to work pretty well. I know, Les, you wanted to talk briefly about the GPIO and hat situation.
Yeah, so with the Raspberry Pi 5, obviously the underlying changes to Bookworm, the Debian 12 OS, means that we have PEP 668 for externally managed Python modules. So now you can't really install a Python module to the entire system, because it may break something that the system depends on, which is absolutely correct, and that's the way to do it. You need a virtual environment to keep it all separate from each other. But the problem we've got at the moment is now the software that's written to work with hats, such as Pimoroni's, Fortronics, that sort of thing, it's no longer working. So you can't just do a pip install to install their software, even in a virtual environment. If you inherit the system site packages, which is one of the options for the creating virtual environments, it still won't install the software for the hat. So I just wanted to talk about that. What's happening in that space? How are we going to get hats working again?
So I'll caveat this with I'm not a software. Well, I know a bit about the software, but I'm not in sort of in the software team. But my understanding is this is a Debian thing, and of course, pip does allow you, or did allow you, to sort of do stuff which would overwrite the system, the system like apt in Debian, the system Python, and in some situations that means things fall over or don't work as you expect. Now, I think I've definitely seen this. There's been active discussion on this for a long time. How do we solve it? And it's very unfortunate that a lot of the hat software is kind of falling down this hole. We're trying to do, I believe, the recommended thing, which is make people aware of it, point them to the PEP 668 description explainer thing on python.org, and certainly for I think Gordon's talking to the relevant actors whose hats aren't working, and through the forums, or either sort of directly well, not just Gordon, the team, and we're trying to help people do the right thing. Now, what exactly is the right thing? I'm going to decline to answer that because I haven't been close enough to the discussion, but it is something we're aware of. We also know it's annoying, and it's again an active thing that we're trying to figure out. And there isn't immediately a good solution, unfortunately, I don't think. But I'm sure there will be in time.
No problem. Appreciate
I know
it.
that's sort of a half answer, but I think it's the only one I can give. Yeah, we're kind of we're in the same situation as other people, really. I mean, it's sort of a, it's sort of, we have to take this stuff as it is. We have only a little control over it, I guess, really.
Yeah, understood. Thank you.
So speaking of Bookworm, one of the things that's changed a lot is the use of VNC. I know we noticed obviously that the VNC is different because you're using WaveVNC. So now you need to use a different client to connect. I mean, I guess that's not really a tragedy, but is that something that's being worked on to have kind of broader compatibility with VNC clients?
So again, you're asking me a software question, but I think I can answer that one. The answer is yes. So I think the underlying issue here is we've moved to using Wayland, which the sort of the brief thing is the X window server, very old, it's been around for a long time. It has a kind of a different way of drawing to the screen, right? There's a sort of split ownership of how you draw stuff. Wayland's a bit different. You kind of get a window to draw in, and then the application is responsible for doing everything. Because that's such a fundamental, difference in the underlying, how the thing actually renders pixels. Things like VNC, if they work on X, if they haven't been updated for Wayland, won't necessarily work at all. I know there's X Wayland, there's a translation layer that you can run.
Yeah.
I assume it doesn't work on that either, and I guess that must be some underlying thing that it's using that it just doesn't work for some reason. This is getting to the limit of my knowledge. Someone will probably say, "Oh, what's he talking about? It's rubbish." But I think that's what's happening. And it's another one of these active discussion areas because obviously VNC is very well used. People, at least there's a workaround for now, but I think the recommendation is if you need to use it like it used to work before, stick with the old software release, and we are working on trying to fix it.
Rightio. Well, let's move away from software. Let's go back to hardware, your comfort zone. So we're talking before the show, and I didn't realize this. I wasn't looking properly, but on the base for Raspberry Pi 5, let me switch to my overhead camera. There we go. You will just about see, if I get a prop to point with, you will see just here, and there's another one just about, sorry, bad eyesight. There's your one. No, that one there. Sorry, that's what I'm looking for. That little silver tab. Now that, when I got this board in my hands for the first time, that completely threw me. I was thinking it's a spark gap or something. But James identified it for me before the show. So James, what is this silver tab all about here?
So you've got that one. You got another one somewhere more in the middle of the board, or maybe towards the other connector. So those are actually replacing. Yeah, that's it. They're replacing the pins that used to be protruding through the board. So this is quite a big Raspberry Pi innovation that people may or may not be interested in, or possibly wouldn't spot when they get their new Raspberry Pi, at least not immediately. But we've moved to using surface mount process for putting all of the parts on the Raspberry Pi. So all prior generations of board, how you build the board in the factory is you get your blank printed circuit board, the green thing. You take a what they call solder paste, which is basically little balls of solder in a kind of a flux type thing. It's liquidy. It's a bit like screen printing. You screen print the solder over all the different bits, the pads, where the component's going to go. You get a machine that literally picks up the little tiny components and sticks them on the solder. and it does it in order so that the small ones go first and the big ones go later, and it doesn't knock the little small ones off. You do that for one side, you put it through an oven and it sticks the components because the solder melts. You flip it over, you do the other side exactly the same way, and then you're left with a board, but no through-hole connectors, no GPIO, no USB, no Ethernet. And then you either by hand put them in, which is what we used to do. We had operators putting in the connectors. These days we have robots who do that. And then it goes through another process called selective soldering or wave soldering, where you basically splash molten solder up on the bottom, and that sort of solders all those pins together. So there's three main processes: surface mount 1, surface mount 2, and then wave soldering. That's on old Pis. On Pi 5, we only got 2. You have surface mount 1, which is the backside, and then you flip it over. You put all the real surface mount components on, and then the machines have been adapted to put the big ones on as well. So we've adapted the machines to pick and place the USB connectors and the Ethernet and the GPIO. And we've also adapted those connectors themselves, so the pins are shorter, the geometry's changed, the hole sizes in the board are different, the pad sizes are different, the amount of paste. You put the paste on the top, you put the pin through it, and then the paste kind of melts when it's in the oven and goes into the pin, right? So it's called intrusive reflow. And that's allowed us to basically make the line a third shorter, take this nasty third process out, which reduces energy use, reduces the thermal stresses on the board, reduces the defect rate. So you often, because you're splashing solder up, you often get little shorts between the pins. I mean, it's still low, right? Maybe 1 in 100, but that all has to be hand reworked. This sorts that problem out, and it looks nicer as well. I think, you know, the bottom of the board doesn't have little sharp pointy things, and flux and so much flux residue. So it's quite, we've invested, I suppose we've been doing this for about 2 years, experiments to try and make this work, figure out how we're going to adapt the machines, do lots of trials with the connector manufacturers, sort of changing the connector profiles, changing the lead length, changing the, all the different various geometry. So it's cost a fair bit in time and effort, but it's really going to pay itself off over the future as we roll this out. For Pi 5, you may well see it coming back onto Pi 4, and obviously future products. It's sort of some people may or may not get excited, but for me, that's been a really cool thing to do, right? And it just makes the product better. And eventually, once we sort of paid off the original cost of doing it, it should help reduce the cost of us to make it.
That makes a lot of sense. Well, I know we've taken up a lot of your time, and we really appreciate it. Does anyone have any final questions for James, either here or in the audience?
I've got a very quick one.
Yep.
James, where's your signature on the board?
Oh, so it's underneath the USB 3 connector.
Right.
So hopefully it's
not station out.
Yeah, hopefully it's not too gratuitous. I kind of think these things are. It takes so long to put them together. It's sort of a little bit of digital art as much as anything. I like to make them look tidy, so I decided to start signing them since Pi 4. But yeah, then it's hidden. So.
Oh, cool! So if you break your Pi by taking it apart, you could see the signature.
Yes.
That's
not worth it right now, folks.
I wouldn't suggest it. I definitely wouldn't suggest it. It's really not worth it.
Yeah.
Okay, so wait, if the Raspberry Pi 5 has been in development, technically going back to 2015, we can assume the Pi 6 is in development right now. So when's it coming out? I'm just kidding.
Oh, we're always thinking ahead. So, Pi 6 is definitely in the mind. If not,
not before Christmas.
Not something I can talk about. No, I think you got a little while till you see that. I'm afraid.
We're just.
Hey, we should we'll get 5 out. We'll get it all nice and stable and improve everything as we do. Get the software nice and sort out all these little niggles and yeah, hopefully people enjoy the product.
I think that's already been determined. People love it. We love it. Wait, we have one more question from our audience member I want to take here. Can both SDIO controllers on the Pi RPI1 be routed to different sets of GPIO pins?
So that's a good question. So the SDIO controllers, so there's 2 on the Broadcom chip, in fact. One talks to the SD card, and that's twice as fast as the Pi 4 one. So SD cards go twice as fast. It does SDR 104 mode. But the other one on 2712, not on RP1, talks to the Wi-Fi. So you might find that the Wi-Fi on Pi 5 is
Oh, yes.
approximately twice as fast.
Yes,
That's
it is.
because the SDIO controller on that is running twice as fast. So that's the reason the Wi-Fi is increased. So we do have SDIO controllers on RP1, but in the end, we didn't use them on this platform because the Broadcom ones, for various reasons, just make sense to plug those things into that chip. But they are there potentially for use in future if we need to.
Fantastic. Well, thank you so much, James. We really appreciate
Thanks,
your
James.
time. We're really
Been a pleasure,
excited
guys.
about everything that's going on with the Pi. Thanks to everyone for watching and listening. Next week we will be back, but it will be 2 p.m. Eastern, but that will be 6 p.m. UK time because you're moving the clock, or was it?
We go backwards a week before the US.
Right, and then so the week after that it'll be 7, but next week it'll be 6. Special Halloween episode with Pimaroni, so very excited there, and we'll see you then.